There are subject matter experts in all of these different areas, and they've figured out what would take you years, a full college education to figure out. There's always somebody who can do what you're trying to get done better than you can.
Hello, everyone. Welcome back to another episode of Manufactured Excellence. I am here with my good friend, Tyler Hurd. Tyler, welcome to the show.
Thank you, Ray.
So I'm really excited to share with you all how I met Tyler. I guess it was in the middle of the pandemic as a lot of startup entrepreneurs were kind of brainstorming and working on their projects. And Tyler was working on some really cool things. And our friend CJ introduced me to Tyler, and just the synergies aligned quickly. And so Tyler came up here to help my cousin and I and the team here at Not Plastic with some prototyping and dialing in the machine that probably a lot of you saw that's right now producing some golf tees. And so be sure to check those out at notplastic.com. But we're really excited for these biodegradable, not plastic golf tees made with a little bit of hemp in there. So be sure to check those out. But I want to start with talking about kind of prototyping and why it's so critical to manufacturing. And you're the best person to talk to about this because it's such a critical part of the whole thing, the whole system. But it's also really challenging, as I have learned and the team has learned over the past year and a half or so, that there's really a lot that goes into the process. And so we've been very fortunate to kind of dial in that process over the last couple of days, and we'll continue to dial it in because you can't have manufactured excellence without manufacturing it. And so that is what we are working on. So Tyler, I'd love for you to introduce yourself to the audience, tell them a little bit about your background, and then we're going to jump in and talk about prototyping specifically.
Sounds great. Well, hi, everyone. So I'm a mechanical engineer, and my background is really in consumer product, physical product design. And I jumped on the Not Plastic team to help them specifically with prototyping small, high volume plastic parts that could be made biodegradable. And one of the things that I'm really excited about with my career is the ability to do this rapid prototyping. So for the first time in history, you really are able to create, you have agility with design and prototyping and creating these very unique products with 3D printing and with the cost of injection molding coming down exponentially over the last couple of decades. So
why do you think it was so high?
Because a lot, it's all about automation. So the way that we get these consumer products out to the masses for as cheap as we can is due in large part to automation. And injection molding is a great form or example of that. But in order to do automation, it requires an exorbitant amount of capital. So really, really large machines, a team of very educated engineers. Traditionally, that's what it has required. But now, some goofball like me can go buy a 3D printer and download CAD models and finesse them, and then print different parts, and then make tooling out of it for small injection mold machines, which is a lot of the work that I'm doing with Ryan with Not Plastic.
You make that sound so easy. Like, what experience do you have that allows you to, because I cannot just go on my computer and CAD something.
Yeah, the biggest I guess piece of subject matter expertise that it would require is 3D modeling. So that's my real niche that I kind of carved out, is 3D modeling of these physical parts.
Have you always been interested in that?
Yeah, well, I've always been fascinated with engineering and creating parts and efficiency. For some reason, I'm just obsessed with efficiency, whether it's recycling, reuse, creating, energy conservation with mass manufacturing. And that's one of the things I love so much about Not Plastic is, the idea that you can create something that doesn't have any effect on the environment, that is completely sustainable. I'm not going to go into how passionate I am about getting rid of single-use plastics, but for me, the jumping off point really was 3D modeling and CAD design.
That makes a lot of sense.
And there's a lot of people out there that can do it, but it's, for the prototyping, the important thing is really understanding just the process of how you get from what's in here to mass production, packaging, fulfillment out to customers.
How does one do that? So for those that are tuned in, I would love to give them kind of the example of the golf ball tee and like how that happens. So a lot of you watched and seen some of the YouTube videos that we've put together and kind of seen some of those different stages. But what was fascinating is, I love that kind of mad science of trial and error. And we tried it the first time, and it did. I wouldn't say it failed, but it didn't succeed either.
Yep.
And we learned a lot. And then we went to the next machine. Then we turned that into a more automated process today. Tyler helped us dial that in, so that's why we're so giddy and excited. But I would love to kind of take them on that journey. So it came to me, a number of people said, oh, I want golf tees. And I didn't really know much about it, but I know people love their golf. Mm-hmm. And so I reached out to you and was like, what the heck do I do? Where do we start? And so if you don't mind kind of walking them through the different stages that we went through to kind of get to where we are today.
Yeah, I'll try to keep it somewhat high level. So it all starts with an idea or a demand. Somebody's, to Rye's point, somebody says, I would love to have this product. Can you do it for me? So before you get to the mass manufacturing step, you have all of these little stepping stones that Rye described. So the very first one is, how do we prototype it? How do we get a physical artifact in our hands that shows the general form of what we're trying to make, whether it's a golf tee or zip ties or dog poo bags, whatever it may be. How do we prototype it first? So the easiest way to do that is, get somebody who can 3D model it and then 3D print it. That would be a good way. Once you have a 3D printed model or a physical rough prototype, then you can take it to the potential customers or whoever is interested in buying it and start gathering this voice of customer. So during this whole process, there's this invaluable feedback loop where you're gathering voice of customer, iterating on the design, and then just doing that process over and over until you get to a design and a concept that has some legs and some demand. So then you take that design and then you'll do what we did and cut small injection mold tooling. We were able to find this really, really neat desktop or benchtop injection mold machine for inexpensive. And, going back to what I was saying earlier, for the first time in history, you could actually get into injection molding, fully automated injection molding for under $20,000. That has never been the case in history. So what we've done is we created 6x6 inch aluminum molds. And for those who don't know injection molding, that's just simply two big chunks of metal that have a cavity carved out, very precision carved out cavity. It comes together, molten plastic gets forced into the cavity, then it cools, the cavity comes apart. And in our case, for fully automatic molding, there's some ejector pins that push the part out. And that's how you have the process of the fully automatic part creation through injection molding. So the steps really are, ideation. What are we trying to build? Is there a demand for it? All right, let's make a prototype of it, get a physical 3D printed part or a silicon mold made, and then just iterate on the design, then cut small tooling. And then you can make several hundred or several thousand parts through that soft tooling. We call it. Aluminum is a soft metal. And then once you've made a couple hundred or a couple thousand, you've proven that people are willing to buy it. There's a market for it. There's a demand. Then you can go spend the much higher level of capital to buy actual steel or hard production tooling for much larger molds and go to what we call a contract manufacturer. They can cut the tooling and then they can crank out these parts at extremely high cycle volumes and low cycle times. And that's the mass manufacturing part. So it's all those little steps to lead up, and you're going to fail probably at every step. If you're not failing, you're not pushing yourself, you're not challenging yourself enough. That's kind of my mentality. So embracing failure is a very important part of entrepreneurship. Yeah. And we all fail constantly, and you have to learn to embrace it, as difficult as it gets, especially through a global pandemic.
Yeah,
it's a hard time.
It can be really challenging. And to that point, obviously there are constraints, time constraints, financial constraints. There's a lot of constraints on production, and there's a lot of constraints that lead to inefficiencies in the process. And I love, because exactly as Tyler just mentioned, the journey of just this little golf tee was ugly and beautiful at the same time. And so we have 2 desktop injection mold units. One is just a very small hand molding unit, kind of crank down. And then the other is that more automated system, which you've probably seen on LinkedIn. And that was that first mold. We tried a couple of different ideas, a couple of different cavities, a couple of different solutions there. And it produced, out of a 4 cavity, 1 golf tee. And that was really disheartening and frustrating when you're so excited, and these things take time. And of course they take money, and that can be kind of a kick in the gut, if you will. But we just kind of called you right back and was like, all right, we need to do this better. We ordered the next machine without really perfecting it on the first one. And that was a risk, the calculated risk that Mike and I were comfortable making, especially with the whiz kid here, helping us out navigating this journey, which I'm sure for you was quite entertaining to watch. And we got this desktop unit. We worked closely with Tyler and decided to kind of go into that phase. And the ejector pins was also kind of another layer that we took a gamble on of including in this, but it worked out beautifully. And now you can see them for yourselves. But I want to ask you, Tyler, as the designer in that process, how do you handle one of the things that I think as an entrepreneur and kind of on the vision side, it can be kind of hard because I'm not very mechanical. So this just goes to prove that anybody can get into this and anybody can really put their mind to something and grit through. But that's from your perspective.
Yeah, that's right. And one of the most important things, the most difficult things, especially for an engineer, is to know when to ask for help. And I think for any entrepreneur, I really like it. Back to the efficiency thing. I really like to, stick to the mindset of not reinventing the wheel and knowing when to ask for help. I love mechanical design. I love CAD design, 3D printing, and injection molding, but there are people out there that do certain things much better than I ever could. So, for the ejector pins, for example, to make the machine fully automatic, you have to have these little pins that are spring loaded that push the part out of the mold. I had never designed that before. So I actually reached out to somebody who had, and they helped me with the design. Awesome. And then I reached out to a mold fabricator who did the actual CNC machining and cutting, and leaned on them for design for molding, DFM. But
what's DFM?
Design. It's either design for molding, design for manufacturing. So whenever you have all of these unique manufacturing processes, be it injection molding or vacuum molding or any fully automated
process. How many different types of molding processes are there?
There are so many.
Blow molding, vacuum molding, injection molding,
roto molding.
What is roto molding?
Roto molding is where you take a giant mold. So the big, they're safes, or they're typically yard boxes with the lids.
Sure.
Those big things. Those are typically rotomolded. They're just giant molds. They pour in this kind of frothed plastic, and then they just rotate it, and it cures as it rotates.
No kidding.
Yeah, there's so many different types of molding. I couldn't even begin to scratch the surface. But the point with that is, there are subject matter experts in all of these different areas, and they've figured out what would take you years, a full college education, to figure out. So it's just knowing when to ask for help. There's always somebody who can do what you're trying to get done better than you can. As an engineer and an entrepreneur early on, I wanted to do everything. I thought I knew how to do everything. And you're just getting in your own way at that point. So knowing when to ask for help is very, very important.
I think that is a critical piece of advice right there. One that I am absolutely learning through this process and others is that sometimes you've got to ask for help, because as entrepreneurs, we're so used to kind of grinding through the day and making it work. But eventually the duct tape model, and duct tape and super glue can only go so far. They're just band-aids. And so it was incredible this week, just kind of as an entrepreneur said, hey, my team needs some help, and we've got a great team, and it's growing and expanding, and I'm just honored to have the people on this project in the kind of not plastic journey that we do, because sometimes entrepreneurs that don't know when to ask for help, the help can show up, and just kind of make it known you might be in over your head a little bit. So I want all of the entrepreneurs to kind of get that theme, because that's something that's hard, for everybody, I think. So how many people does it take? So when you're looking at creating a prototype mold, like how many people were on the golf tee project?
So we had probably four people, me really doing the project management and initial design work, and then a fully automatic injector pin kind of DFM engineer, design for molding engineer, and then the machine shop who did all of the final tweaking and the assembly and the testing, and then they shipped it over. So myself, DFM engineer, and a couple machine shop people.
That's incredible.
And that's a very small team, and that's the real beauty of a small startup or any entrepreneur. You always have to remember that your biggest strength is agility and being able to make decisions and execute quickly. There's just no way to compete with these really large manufacturers who have these injection molding machines with 20 cavities that are cranking parts out constantly. You just can't compete with them on price, but what you can compete is on agility. So you can create new parts, you can innovate. But again, with that comes a lot of failure. So you just have to learn how to embrace failure, know when to ask questions and who to go to seek help. One of the things that I learned very quickly was, you're taught through school, when you get your first job, you're taught to be a subject matter expert, whether it's as an attorney or as an engineer or as an accountant. But when you create a business, you have to be all of those things, but you can never do any one of those things super well. So you have to know who to go to do those things well. So it's a lot, but that's one of my favorite things about being an engineer and an entrepreneur, is understanding how to make physical parts from the ideation process through prototyping, and then full automation creation.
That's so. If you were just somebody on the outside looking in, and you had a product idea, roughly before now, what would it take financially? Like, what would that investment be for somebody to try to get in and just like the golf tee, like just one product?
Yeah. So if it's a product like the size of a golf tee, or say a cell phone case, something to that size, very first thing is make sure that there's a market for it. Make sure there's a demand for it. You can spend an inordinate amount of capital making these parts and then not be able to sell them. So first, make sure there's a demand. Get your buyer. I heard a quote, I can't remember from who, but it was the best way to get into this game is find your buyer before you make the product, rather than vice versa. So find a demand first. Find some sort of demand for a product, and you can create small volume parts for as low. I think you could probably do it for $10,000 to $15,000. For 3D printing, you could go to Upwork, you could find a 3D modeler, get the CAD models made, and then have it 3D printed, or have a silicon mold that's like a single use or a couple uses. You could do that for a couple $1,000s. So there's not a very high capital hurdle to get to that prototyping stage. It's just how do you get from that 3D printed part? Because anybody can go and buy a 3D printer right now and make a part. But how do you get from there to mass manufacturing and get the cost of, say, a golf tee down to a couple cents? That's where the magic happens. You just have to know who to go to for what and what to expect. And that's the process that I've kind of become very intimately familiar with and working to perfect. I don't know if I'll ever get there, but
no, we strive for perfection, knowing that we will never reach it.
That's right.
One of the things that I love about Not Plastic really taking on this kind of innovations and prototyping is it's always so exciting. I think that's where the mad science comes out. It's like the failure makes the successes feel exponentially better. If you're just winning all of the time, I don't want to say you would get bored of winning. I mean, I guess we could ask like Tom Brady, but I don't think anybody gets bored of winning. But you definitely taste different.
Yeah, and also failure is such a better teacher than success.
Yes,
you know, there are a few things that stick with us longer and more vehemently than a failure. You know, especially if it's a public one or. You know, but success, it's like, yeah, I did it well, it worked. That doesn't quite stick with you the way that a failure does. So I'm a big proponent of embracing failure and just as long as it only happens once.
Yeah,
try not to make it happen more than once.
No, that's great advice, and I'm so excited because we got the machine up and running today, and it was cranking for about an hour or so, I think. And now we're looking at what's the next phase of that. So we did the hand mold. Did we print the golf tee?
We did. We did an SLA print for the hand mold.
That's right. And then we did the desktop molder that we're using now. And then we are looking for the right types of partners that have injection molding equipment that want to do golf tees at scale. Because it really is important. To your point, we kind of did that because we heard some of our friends, oh, I could put this here, I could put this there. And then it's really kind of looking for that buyer going into mass production that makes sense. And that's something that I think everyone struggles with. And that's kind of the dream. And it's challenging to get there. And so there's these kind of steps in the process. And so now we've got that's going to that next phase. The golf tee is going and kind of looking for that mass buyer, that mass producer, and then looking at other products that align within the Not Plastic ecosystem, within the kind of the family of the systems that we have up here. And it's really fascinating because there's so much overlap. And I think you make connections sometimes that don't always, make sense, but they work out in the long run. And so that's been one of the fun things that I've kind of experienced through this is trial and error of kind of throwing some of those concepts up against the wall and seeing what sticks, and then refining what that looks like and bringing that into something real.
Yeah, that's my favorite thing about designing physical products is you can put your hands on it, you can break it. A lot of entrepreneurs are going into SaaS, software as a service, and different digital infrastructure and technology and that sorts. I'm not a big fan because I can't touch it. I can't, make it from a machine and hear it. I'm just very mechanical in that respect. But that's one of the things I love about Hardware Park. I'm based out of Birmingham, Alabama. The shared workspace that we have is called Hardware Park, and all of the startups there focus on physical product development, design, manufacturing, etc. But yeah, I'm a big physical product guy.
So when you hear the term manufactured excellence, what does that mean to you, and what does that look like?
To me, that's again back to the efficiency obsession that I have. That really comes down to process automation and perfecting a process. Because with physical consumer products, especially commoditized products like golf tees, the name of the game to succeed is simply volume. It's just high volume for as inexpensive, cutting out all the waste that you can. Waste being time, material, any expenses you have to cut that down so that the process is extraordinarily streamlined, from getting raw material in to transforming it into a product to shipping it out to a customer, fulfilling those orders. Everything throughout that chain, that value chain, has to be extremely efficient.
And before we wrap today, I'm curious, Tyler, how does one build an efficient supply chain, an efficient value chain?
That is $1 million question.
And then some.
Yeah. People make a very successful living answering that question. It's a lot of time. It's a lot of time and a lot of capital equipment costs. Fully automated equipment, assembly lines, molding machines, they're not cheap. They're very expensive. However, I do not encourage anyone to go out and buy the equipment themselves and set it up themselves. Find a contract manufacturer who specializes in X, Y, and Z, whatever you're trying to make. Amazon is a great example. So FBA, Fulfillment by Amazon, they have perfected fulfilling orders. So you ship a pallet of your product, of your golf tees, 100,000 golf tees on a pallet. You ship it to their warehouse. Every time an order comes in, they fulfill the order. They put it in an Amazon box. They ship it out. They take the returns. They deal with customer service. They've streamlined that incredibly efficiently. So that's just an example of order fulfillment. Injection molding is the same way. You can find large contract manufacturers who are incredibly efficient at injection molding. The difference with them, you obviously have to purchase a tool, and that is a pretty large cost. But I think a lot of entrepreneurs fall into this trap of trying to do it themselves or thinking they have to do it themselves. That's just not the case. What we're doing with Not Plastic, with the prototyping and starting small volume and then going to an automated small benchtop model, allows us to create hundreds or even thousands of parts to find buyers and find demand for, at which point we can then go to a contract manufacturer and create 100 times the volume for half the price. But again, to get to that manufactured excellence point, to me, it's really how well you manage resources. So you find the fulfillment by Amazon, order fulfillment piece, you find the injection mold or automation piece, and you put all of these together and you manage them. You find software that can speak to all of the different groups and just find a really good automated process that ties all of these resources together and automates it to the best that you can get to. That's amazing. So we talked about prototyping and kind of the way that it had always been done in the way that it can be now, which I'm really excited for because it gave us that opportunity to help make some of your ideas a reality, because all of the ideas that we've been playing with have come from all of you. So that is amazing. Keep the ideas coming, of course. And Tyler, how does the audience stay connected to you? You can find me on Twitter. It's Ty Water Guy at Ty Water Guy. LinkedIn, Tyler Hurd. And I would love to hear from anyone. And I always love to hear product ideas from the masses. It's where the best ideas come from. I've got to get out of my own head sometimes and ask people for ideas. So please reach out to me. I would love to hear from you. And Tyler, you are also working on some amazing projects of your own. So I was wondering if you would like to share a little bit about some of those projects. Sure. So my baby right now is a company called Water, and what we're doing is purifying water. Is that Some or Sun? Some, thank you. It's SUM, like drink some water, spelled SUM. And it's actually a project that I've been working for about 3 years on under a couple different company names. And the idea is to create purified water that's dosed with flavoring, vitamins, minerals, supplements, and you can customize your beverage on demand. It dispenses it into a reusable bottle. So it creates, functional, healthy beverages without the single-use plastics. That's amazing. And so what is that website for everyone to go check out? That is drinksomwater.com, SUM water. That's amazing. Well, Tyler, thank you so much for joining me today. Thanks, bud. I'm glad to be here. Of course, super grateful to all of you for tuning in as well. Be sure to stay tuned and follow us, Manufactured Excellence. We'll see you in the next show.